Algebra 2, Target 25. I can sketch the graphs of simple exponential and logarithmic functions. Today we're going to focus on the exponential functions, exponential growth and decay. You may remember y equals a times 1 plus r to the t, y equals a times 1 minus r to the t. Those are the types of functions we're going to graph today. And they're going to follow the growth and decay models that we've had before. The parent function for all exponential growth, y equals b to the x, they should look very familiar to what you did before. The difference is you got no starting value there. That means we're starting at 1. And your growth rate there is b. So whether b is 2 or 4, doubling or tripling or quadrupling, that's what you're looking at there. A couple things I want to point out. Right here, that graph, it appears to be leveling off. And it is leveling off, but what's really happening is it's approaching an asymptote. An asymptote is a number or a line that a graph gets closer to at extremes. It may or may not cross it. In this case with the exponent, it does not cross it, but it's going to get really, really close. And in a growth function, from the left side, it's really, really close to it on the left side, or at x values of really negative values of x. For decay, it's going to go like this and get really, really close to 0 for very large values of x. Another thing I want to point out is this value right there. That's our starting value. All right. In this case, there was no starting value there, so it was a starting value of 1. So that's why it goes through your y-intercept was 1. And then when you plug in 1, you get your second number. That's your growth rate right there. So when x is 1, y will equal your growth rate, b. And then if you go backwards, if you go forwards, you'll continue to multiply by b. If you go backwards, you're going to divide by b. So if you got the point here at -1, that'll be 1 divided by b, because you're going exponential growth backwards. So if we look at a couple examples here, or again, here's the decay, same thing. Pay attention to your asymptote. There's your asymptote. It's approaching 0 to the far right. There's our starting value of 1. Notice there's nothing multiplied out front. That's why it's a starting value of 1. And as you move further to the right, your multiplication factor, your growth or decay factor is right there. If we go backwards, this would be the point 1 and then 1 divided by b. Right, so let's look at a few examples and see what's going on. Some key things to remember: the general shape, it's going to be a J-shaped curved. It's kind of either really flat and then climb up accelerating, or it's going to decelerate down and kind of level off. You're either going to have your asymptote on the left here or on the right. Either on the very far right or the very far left. Very far left if it's growth, very far right if it's decay. Make sure your asymptote is clear when you graph it, and make sure you have 3 points clearly marked. When x is 0, when x is 1, going forward, multiplying by the growth factor, and when x is -1, going backwards, dividing by the growth factor. All right, so let's take a look. Graph the function y equals 1/2 times 4 to the x. We are starting at 1/2. So at x equals 0, that is our starting point. We're starting at 1/2. Now, we know it's growth because that's positive, or that's greater than 1. So it's going to be the general shape where we start low and climb up. The asymptote's going to be off to the left side here. Now, our first point at x equals 1 is going to be 4 times larger than our y-intercept. And if our y-intercept is 1/2, we're going to take 1/2 times 4. Our first point at x equals 1 should be 1, 2. Going backwards, you should take 1/2 divided by 4. That's the same as 1/2 times the reciprocal. So going backwards, we should be at the point -1, 1/8. It's really hard to draw because it's so small. And then we're going to have our basic shape. We got our steady exponential growth through those 3 points. Okay, here's another example. We take a look, we start at -1 because our value up front is -1. So we'll plot -1. This is a little different because it's starting at negative. It's going to be growth because this is larger than 1, but it's not going to look like that because of the negative. Because of the negative, we're going to take that shape and it's going to flip down. Right? So it's going to flip down. So watch what's happening here. Our second point, our first point is -1 when x is 0, y-intercept is -1. Our next point we're going to multiply by the growth factor. So that'll be at -5/2. So when x is 1, we'll be at -5/2, which is about 2.5, or -2.5. Then we're going to work backwards. We've got to take our -1 and divide by 5/2, which is the same as multiplying by 2/5. Dividing by a fraction is multiplied by the reciprocal. And that works out to -2/5, or about -0.4. We can see we're going to have our asymptote here. And then it's going to grow in the negative direction. All right. Take a look at this example. Find your starting value. Is this growth or decay? How can you tell? It is growth. It is decay. Sorry, pardon my mistake. It is decay because our ratio is less than 1. So this is going to look like this. It's going to start high and level off. So our starting value is 2. And as we move further to the right, at x equals 1, we're going to take 2 times 1/4. That's going to give us 1/2. So at x equals 1, the y value is 1/2. And as we move backwards, instead of multiplying by the decay factor, we're going to divide by it. So we'll take 2 divided by 1/4, which is the same as 2 times 4 because you multiply by the reciprocal. And so at x equals -1, it's going to be at 8. And so it's going to decay and level off, approach, but don't touch the asymptote. Pause the video and try this one on your own. All right, we can see we have a starting value of negative. So it starts at -3. So whatever we see as a growth or decay is going to be reflected down. It's going to be upside down. It is decay because our ratio is less than 1. Go through and find our next number. We start at -3. To get the next number, we multiply by the ratio. -3 times 2/5 is -6/5, which is about -1.2. So at x equals 1, the y value is -1.2, which is approximately there. At x equals -1, we take our starting value and we divide by the growth rate, or the decay rate in this case. So we'll take -3 divide by 2/5, which is the same as -3 times 5/2, because you multiply by the reciprocal. That's negative 15 halves, which is negative 7.5. So at x equals negative 1, we're at negative 7.5. Plot your 3 points, and we got our exponential curve, in this case a decay curve that goes through it, approaches our asymptote out there. Just like that. So, in summary, the four basic steps for graphing y equals a times b. Identify an a and a b. A will be your starting value or your y-intercept. Okay. B, that'll let you know whether it's growth or decay. Does it go up or down? Does it approach the asymptote for large values of x or small values of x? Identify the asymptote. Is it on the right or the left? Normally the x-axis. Plot some points. I always start with 0 when x equals 0. And then move on, do when x equals 1. Then go backwards and do when x equals negative 1. And then through those 3 points, you're going to draw a J, either a growth or a decay J, or, if necessary, reflected growth or decay J's.